Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 19th, 2025, about 3 days ago, and this paper has been getting a lot of attention. The headline result is clear. The model surpasses leading large language models like Gemini 2.5 Pro and DeepSeek R1 by up to 46% on molecular tasks and 66% on reaction tasks. The paper is titled, Chem-R, Learning to Reason as a Chemist. And as we'll see later, the gains are broad and interpretable. In short, a three-phase pipeline combines chemistry foundation training, distilled step-by-step reasoning protocols, and multitask group relative policy optimization to deliver reliable chain of thought and balanced performance across molecular and reaction problems. Also, the authors shared a GitHub repo. You'll find the Phase 3 training code built on EasyR1, implementing multitask GRPO for chemistry. It includes setup steps, a quick start bash script under EasyR1, dataset hooks across molecules and reactions, task-aware data formatting, and reward metrics for granular evaluation. Alright, Figure 1 summarizes the problem and the remedy in one view. The left panel illustrates 3 failure modes, including misreading smiles, which is a text line notation for molecules, and IUPAC names, plus messy reasoning and lopsided task performance. The right panel presents the 3-phase fix: foundation training, protocol-guided step-by-step reasoning, and multitask group relative policy optimization, which re-weights tasks so weaker ones improve. Alright, Figure 2 presents the end-to-end training pipeline that turns ad hoc reasoning into consistent chemical thinking. The left panel shows Phase 1, where supervised fine-tuning grounds the model in valid names, smiles strings, and reaction mappings. The center panel details chemical reasoning protocol distillation, which means extracting reusable step-by-step templates so chain of thought stays structured and cautious. The right panel introduces multitask group relative policy optimization, which reweights tasks during reinforcement learning so weaker skills improve without hurting strong ones. So Figure 2 laid out the training pipeline, and Table 1 reports head-to-head performance across molecule and reaction tasks. The table shows that Chem-R at 8 billion parameters leads most columns because structured reasoning and task reweighting prevent trade-offs. Yield prediction reaches 0.85, which indicates far better accuracy in estimating product amounts. Retrosynthesis reaches 0.39, meaning the model more often plans the reactants that produce a target molecule. While Table 1 showed headline gains, Figure 3 explains where they come from. The panels trace steady lifts from foundation training to protocol distillation to group relative policy optimization, which stabilizes learning so scores keep climbing. The sample size study shows clear diminishing returns once K approaches about 10. The time plots indicate Phase 3 continues to nudge molecule and reaction metrics upward. The rightmost bar chart shows much stronger success on unseen optimization tasks, which signals real generalization. So Figure 4 presents the human expert radar chart comparing reasoning quality. The radar chart places 6 dimensions on spokes, and larger radius means better performance. Chem-R forms the outer shape because experts judged it highest on chemical soundness and logical coherence. The model also leads on clarity and conciseness, an expert-level insight, indicating reasoning that is both readable and defensible. Against Gemini 2.5 Pro and DeepSeek R1, the margins appear consistent across categories. Wrapping up, 2 takeaways stand out. The 3-phase pipeline turns large language models into consistent chemical reasoners, and the 8 billion model delivers broad state-of-the-art accuracy with interpretable step-by-step logic. The broader implication is practical: reliable assistance for reaction planning and discovery, accessible beyond giant labs. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.